see some of the applications. So till now, within the given time, how much I'm able to share, I'll be able to share you. So we'll be able to automate our own home and whatever watch we are wearing in our hands. So that can be a smart watch, and nowadays we have smart TVs, and entire device in our home can be automated. So in early days and all, this was a dream, but now we'll be able to automate each and every device, whichever device we handle in our hand. Everything can be automated because science is evolved in it has reached a milestone in such a way that everything can be automated. So that's what we're going to see today. And we'll first see the evolution of IoT, how IoT evolved. I hope my slide is changing, sir. Is my slide changing? You are able to see the slide evolution of IoT, right?
Yes, ma'am.
Okay, sir. So in early days, in 1990s, you see.
Ma'am, can you unmute your mic, ma'am?
So is my voice audible?
Yes, ma'am, it's now audible, ma'am.
So we'll see the evolution of IoT. So during the year 1990s, we'll be able to connect our desktops and laptops through the internet. So internet will be connected only to the computers. But when we reach the year 2000, we have our smartphones, and the smartphones and tablets will be connected to internet. Actually, in early days, if you see that, we might have used only the button phones. So we were using only button phones, and there's no chance of connecting internet to that mobile. But when we reach 2000, we are able to connect internet to the mobile phone. So whatever device we have in our hand, each and every minute, we are using a mobile phone that is with the internet. So this is what the evolution of science. And later days, when we cross 2015 or 2020s, billions of objects are being connected to the internet, and we are able to communicate, and we are able to automate each and every device. So every day, whatever we use in our own home, that can be automated. Actually, you might have heard about cloud computing. So in cloud computing, we can store the data and we can process the data. So only for the purpose of storing and processing, we were using the cloud. But after that, we had artificial intelligence. So when the evolution of artificial intelligence occurred, artificial intelligence is able to make decision, and so many things will be able to automate. So nowadays, whatever decision we want, immediately we'll go to ChatGPT, we'll type the question, we'll be asking for the solution. But previously, if we want any solution, we were finding it very difficult. Even while we are doing our PhD's research work, that was very difficult before the evolution of artificial intelligence. Whenever the evolution of artificial intelligence occurred, everything is made easy. So we can get any solution through decisions given by AI, and it is able to correctly judge, and it is giving a decision which is very accurate. And even in networks, we are coming across 5G networks. So we are able to process everything with a very fast speed, and everything is now within a minute we'll be able to access, and we'll be able to get the things done within a fraction of second. So evolution of IoT has so much affected the entire world. It is not only what to say, earlier days whenever there was the evolution of mobile, so many people might have thought how this mobile phone is going to reach each and every individual, because we thought that only educated people might be able to handle mobile phone. Even I had a thought that how uneducated people will handle mobile phone. They should know the operation and they should know each and everything in the mobile. But nowadays, no, not even a single person without mobile phone. Each and every person is having mobile phone. Even those who are selling fish, those are there in the vegetable shop, they are able to operate the mobile phone, because science has developed in such a way that it made easy. IoT has made easy for each and everyone. Everything is user friendly. So each and every person is able to operate the device, and everything is automated also. So if it is of manual handling, it might be very difficult for each and every human being to handle. Since it has been automated, it has made, IoT has made things very easy. Even the uneducated people, they are really able to use the device without any difficulty. So we'll see the IoT architecture. So basically in your IoT architecture, there are 4 layers: application layer, processing layer, network layer, and perception layer. So in application layer, we'll be able to get the service and user interface that provide value to end users. In the case of processing layer, you'll be able to process the data, and you'll be able to store the data, and you can collect the data, make the decision. And in the case of network layer, data can be communicated or transferred from one place to another place, from one sensor to another sensor, by making use of the cloud storage. And then we have the perception layer. So in perception layer, we'll be able to handle the sensors and devices that collect the data and that will process the data. So this is what the IoT architecture will go into the applications of IoT. So first thing in IoT, it has made a revolution in our own home. So if you take our own home, our entire home can be made as a smart home. We can convert our entire home into a smart home. So smart home in the sense everything can be automated and everything can be monitored without the intervention of human being. Even though you're not there in your own home, everything can be monitored. So that's what our IoT has made each and everything easy. So we have our tube lights, bulbs, everything in our home. Even if we forget to switch off the tube lights or bulbs in our own home, if we are working, if we left the house as it is, we'll be able to turn on and turn off the lights if we are there in a working place. So that is what the main thing which we can automate our home. And not only lighting, in some other countries, they require temperature. In very cold countries, they require temperature. Here we are using air conditioners, air coolers, but in like foreign countries, they may be requiring heaters. So we'll be able to control the temperature as well as the cooling effect of the entire room if we have our IoT device. So if we have the thermostat, we have a device called thermostat. So that thermostat will control the temperature as well as the even if it is if your room temperature is very cool, it will maintain the temperature. If it is very hot, it will make it cool. So according to the temperature of the room, we'll be able to automate how the room should be, whether it should be cool or it should be heat, that we can decide. So we can automate that. And apart from that, we also have smart door locks. So you will be able to control automatically your doors. So we need not go to the door and we need not make a lock to that. So we'll be able to automatically make the door close and open. We have biometric doors also. We can keep a security in such a way that whenever we go and stand in front of the door, after recognizing our own face, the door may be able to open, and without we going and standing in front of the door, if other person are coming to or trying to open your door, it will not be able to open the door. So if any thief, if he wanted to intervene into your house, we can automate a home in such a way that our mobile phone will be receiving a message saying that some other person wanted to open the door. So we can keep our home highly secure. We need not be in a fear that how safe our home is, because IoT has made our things very secure. So not only that, we also can keep security cameras in a house. So we can keep the camera, we can monitor that. That camera can be connected to our mobile phone. We can watch whatever is going on in and around our house, visiting in our own place, wherever we are. If we are working in our working place itself, we'll be able to monitor the entire home by just keeping a security camera. And apart from that, we also have Alexa and Google Assistant. You might have heard in so many people they are using this AI, and this will remind you of things. See, if we have something, some tablets need to be taken by us. If we are having a habit of forgetting that, we can keep an alarm in Alexa, and Alexa will remind you saying that you need to take tablets in this particular time, and you need to go for walking in this particular time. Likewise, we'll be able to get the things done by Alexa. It will remind you of the things, even if we have the habit of forgetting the things. So IoT is actually playing a vital role in each and everything. Whatever way we want to use IoT, we'll be able to use that. So highly IoT has developed, and in our home, we'll be able to monitor the water level. So it is not that only you can keep your home as a smart home. We can also control water level. In early days, whenever we wanted to use our water tank, we'll be using the switch to turn on the motor. After we turn on the motor, we have to check whether the water tank is full or not, and we'll be having a pipe. It will actually, whenever the water is coming out of the pipe, outlet is there, then only we'll be able to understand that okay, the tank is full. But nowadays, that also can be automated. So we can have a automation to detect the water level itself. So in our water tank, we can use ultrasonic sensor, which will measure the water level, and you can process the data using ESP32, and your AI model will analyze the data, and it will give you the information through the LED and also to your mobile phone. So we can design a circuit so that you can automate and you can identify the water level in your own water tank. So you need not go to the water tank, and you need not check every time whether the tank is full or not, whether we get outlet from the water, whether it is full or not. So we need not check at all. So we have a system, we have an IoT system which will automatically identify. We have so many sensors. So each and every sensor is having a different ability. So sensor will detect the water level, and it will send the information to LED as well as to mobile phone. So we can automate each and everything in our home. This is one of the application to make your home smart. And there are so many advantage for making a home automated. So we can use any machine learning language to automate our home. And actually manual water level monitoring is slow, and it is also inaccurate. And there may be some wastage of water. So already we are in water scarcity, and we don't want to waste the water. So IoT is very helpful, so that we can preserve our water, and we can also get each and every information in our hand device. So we need not waste the time, we need not waste the water. Since we have a device for each and everything will be automated, and everything will be monitored by us. Even we need not keep a separate person to monitor in and around the house, or we need not go for any security. Each and every security is available if we use an IoT device. And next we come across smart healthcare. So actually IoT is not only dealing with devices. IoT is playing a very vital role in each and every one of our healthcare. So if we come to healthcare, patient monitoring is actually very, very important. Even if the doctor is physically not present in the hospital, if the doctor is not with the patient, doctor will be able to get each and every information about the patient by using IoT devices. So there are so many wearable devices which will help doctors to get the information about patient. See, nowadays each and every person is having smartwatch. See, before and all, we used to go for devices. What is the pressure and what is the pulse rate? We have to go to doctor. We have to check. But nowadays, we need not go to hospital. We need not go to doctor to check the pulse rate or to check my BP level. I have a device on my hand. For the entire 24 hours, I will be able to wear the device, so that device will be able to give the entire information about my body health. So what is my body mass index, and what is the blood pressure, and what is the pulse rate? Everything will be monitored by a simple smart watch. So the entire world is in our hand. That's what IoT has made. So there are so many wearable devices, not only this one. In early days, we were using pacemaker to track the working of heart, and health monitoring. So many health monitoring systems are available, and also telemedicine is available. You need not in person go to the doctor. Now by means of telemedicine, we'll be able to get connected to the doctor in our own home. From our own home itself, we can get connected to the doctor. Doctor will be suggesting you about which tablet you wanted to take, and actually what you are suffering from. So if you actually want any counseling, or you wanted to get clarified about your intakes, any tablets, that will be done through telemedicine. So if you are really very you're in a requirement of doctor, you can go to the hospital. Nowadays everything is made easy, so we need not for very small things, we need not go to hospital, we need not stand in a queue, we need not waste our entire time. So we can save so many times, and even the disease can be detected early. So before the disease gets worst, if we are able to do screening, continuous screening can be done in our home itself. So we need not go to hospital for screening. Early days, whatever checkup we wanted to do, we have to go to the hospital, and only with the help of the doctors and nurse will be able to get help. So nowadays, if we wanted to get it clarified, if I have some any disease I am affected with, if I have any problem, sir, Sabrina sir, can you mute your mic? Sir, can you mute your mic? So early detection of disease can be done by means of IoT. Take an example, detection of diabetic retinopathy. Sabrina sir, can you mute your mic? Is my voice audible? So I'll take an example of duration of diabetic retinopathy. So this is the retina of the eye. Sir, is actually disturbing, sir. Sabrina, sir. Anyone ask him to please mute the mic? Sir, is my voice audible? So we'll see about diabetic retinopathy. Um, this is the retina of the eye. In this retina, there are so many parameters present. You have the optic disc, you have the blood vessel, you have the hemorrhage, and you have the exudate. See, actually, this is the optic disc of your eye, and you have the blood vessels. So, blood vessels are like whatever vessels, whatever nerve we have in our entire body. Likewise, we have a nervous system in our eye. This is the internal structure of the eye. Many organizers present, please mute the mic of Sabrina sir from CMS College of Engineering. Thank you, sir. So we'll see the detection of diabetic retinopathy. So each and nowadays, most of the people are affected with diabetes. Early days, if you see, if you want to check whether I have diabetics for me, I have to go to the hospital. I have to do sugar test. Then only I'll be able to understand whether I have diabetes or not. But nowadays we have our smart device in our home itself. We'll be able to check. We can do the blood check, but what the IoT actually is doing is before you get diabetes, you will be able to understand that you are going to get affected with diabetics if you are continuously screening your eye. The main thing which will get affected if your diabetes level is very severe is your eye, retina. So retina will be highly affected if the diabetics prolongs for years, if it is going to a very severe level. But what happens is before the occurrence of diabetics, some changes will occur in your own eye, in your own retina. So as if you are continuously screening your eye, if there are some changes in the eye, you will be able to understand that you are going to get this diabetes. So before the occurrence of diabetes itself, you can take precautionary measures, you can take the medications, you'll be able to get rid of that. So what are all the changes occurs when a person is getting affected with diabetes or before the occurrence of diabetes? This is the, I think my screen is visible and you're able to see this retina. So in this retina, you have the optic disc, the circle thing, that is what called the optic disc. So, you have a nervous system inside the retina. Like how we have nervous system in our entire body, likewise, we have nerves in retina in our own eye. That is what called as blood vessels. Blood will be flowing in that vessels. And one more thing is called hemorrhage. It is marked as hemorrhage. Hemorrhage is nothing but blood clot. So these are all abnormalities. This hemorrhage and exudate, these are all abnormalities. So whenever there is a blood leakage from this blood vessel, we call that as hemorrhage. And sometimes there will be protein leakage in your own eye. You will get protein leakage. That protein leakage is what called as exudates. So these are all the various parameters which will affect your retina. So if your retina is not proper, if your retina is about to get affected with diabetes, any one change will occur in your eye. This optic disc will be bulged, your blood vessels may be bulged, or it will break open and it will leak blood, and blood spots will be there. That is what called as hemorrhage, and protein leakage will be there. So these are all some of the parameters which will affect your eye, some of the things which will affect your eye if you are about to get diabetes. So if you are continuously screening your eye, if any change occurs in your eye, you can understand that I'm going to get affected with diabetes. So I need to meet a doctor, I need to get medication, I need to get treatment. So this screening can be done on your own. It is not that every time you have to go to the doctor and do the screening. See, nowadays we are doing health checkup, right? For once in 3 months or once in 6 months, we are going to the hospital and we are doing health checkup. But IoT has made everything smart and everything very easy. There may be handheld device, but right now there is no handheld device developed. But in future, you might be having a device in your hand. Even your mobile may be having the facility of capturing the photo of your eye, and that photo can be processed in that device itself, and you'll be able to get your mobile itself will be giving you the information saying that these are all the abnormalities, and these are all the things you need to concentrate. So that things can be done by using your mobile phone itself. That facility will be available. Veena Sundaresan sir, can you please mute your mic? Veena Sundaresan sir. So in order to do the screening, in order to automate this system, in order to automatically detect. Veena Sundaresan sir. Thank you, sir. So this is what the various parameters which will affect our eye. So this screening can be done with an automated system. So we have an automated system which will do the screening. So you need not every time go to the doctor. For once in 3 months, people will be doing a sugar check. Sugar checkup will be done by patients. So we can do the screening in our own home if this system is automatically if this automated system is developed. So right now it is under process, and a handheld device is not available, but you'll be able to get the things done. But a handheld device is not developed, it is under process, and we can develop a system called computer aided diagnosis system. So using this computer aided diagnosis system, this is an automated system which will give you a result saying that whether you have any problem in your retina or your retina is normal. Whether your retina is normal or abnormal, that can be checked, and the result can be given by this computer aided diagnosis system. This is a CAD automated system. So input image of the retina, input eye image will be captured, and that is given as an input that will be processed, filtered and equalized, and actually final output what we are getting is blood vessels. So normal eye will be having some thickness like 0.9 micron. So that is the actual thickness of your blood vessels. So if the blood vessel thickness varies, if it is somewhat with a different thickness, then from the result what the automated system is giving, from that we can identify whether my blood vessel is normal or abnormal. Not only blood vessel, it will also give you the output like optic disc, exudates. I was showing circular thing, optic disc. So that is the center of the retina. So if that optic disc is somewhat bulged, that can be detected by the automated system that will extract the optic disc, and that will show you whether any changes in the optic disc, or sometimes there may be protein leakage. That is what we have seen as exudates. So if you have any protein leakage in your eye, that can be extracted separately, and that can be shown, the result can be obtained as there is a presence of exudate. So you can see in this image that F image is showing optic disc and G image is showing exudates. So wherever there is a presence of exudate, this G image will be there. It will tell you that you have the presence of exudate in your own eye. And in F image, if something is wrong with your optic disc, it will say that your optic disc is bulged. It is not normal. And your E image says that your blood vessel thickness varies. So actually, if there is any change in any of the parameter, your automated system will tell you that these are all the changes which is occurring in your eye. You need medication, you need to meet the doctor. So this is actually screening process. We are not doctors. Actually, we are engineers. We can help the doctor. We cannot become a doctor. We can help the doctor, saying that this is what the thing actually present in the eye. So we are helping the doctor, and we are reducing the patients continuously going to the hospital just because of screening. Just for the sake of screening, they need not every time go to hospital. Very frequently, they need not go to hospital. If actually there is a change occurs in the screening test, if any problem is there, if it is identified as abnormal, then in that abnormal condition, they can go to the hospital, they can go to the doctor, they can meet the doctor in person, they can get it treated. And occurring of a disease can be avoided if a continuous screening is done. So this is an automated system which will tell you whether you're affected with any particular abnormalities or not. So this is what your IoT is actually helping you to do. This is an automated healthcare system. And next we come across smart agriculture. Not only in healthcare, your IoT plays a vital role in agriculture also. So in early days, farmers actually need to monitor the crops, and they have to check the soil condition, and the entire day they have to stand in the sun and they have to work for their own farms. But nowadays IoT has made that also very easy. So they need not check the soil, and they need not go and water their crops, and they need not apply the pesticides or whatever it is. They need not suffer for irrigation. Everything is done automated by IoT. So we have a soil moisture sensors. So that soil moisture sensor will check the water quality. If actually the water is very dry, if actually the soil needs water, then automatically the system can irrigate the soil. And depending upon the weather condition, depending upon the climatic condition, whether the farmer has to plant or whether he has to harvest, that decision can be done. And weather monitoring can also be done by IoT. And not only that, recent development is like we have agricultural drones. Drone is not only used in taking photos or moving into some other place. It is actually useful in defense. It is also useful in farmers. Farmers are highly utilizing these drones because they need not all the time go for sowing their seeds, and they need not go and use all that pesticides. By using the drones for some acres, the instead of manpower, the drones will be able to sow the seeds, and the drones will be able to place all the pesticides within a minute. So time is actually highly saved, and manpower is also saved. So they need not the entire day stand under the sun, and they need not get suffered. So everything is made very easy. So nowadays, this agriculture is made easy for farmers. IoT has changed everything. It has made a revolution in agriculture also. So this is a IoT based smart agriculture system. So we have an Arduino board, and we have different sensors. We have a moisture sensor, and we have a biological sensor, water sensor, and sound and motion sensor, temperature and humidity sensor. So all these sensors will check the quality of the soil, and it will give information by means of relay or by means of buzzer. So by checking the quality of the moisture, the relay will turn on the water pump. If actually the soil is in need of water, the relay will turn on the water pump. Water will be given to the soil. If there is no need, it will be automatically switched off. And we also have a buzzer indication. If anything is needed for the soil, we can keep a buzzer. It will indicate the farmer saying that soil is in need of water, or something else is in need of that. That can be done through the buzzer indication also. So everything is now made easy by means of cloud storage and by means of internet. So each and everything is connected through the internet, and everything is made easy. So we can make agriculture also as a smart agriculture. So there are so many advantages of using smart agriculture. Manual monitoring is not needed. So decision making is highly made easy, and human error can be avoided, and human labor is also reduced, minimizing the resource wastage. So these are all the advantages of smart agriculture system. And next, what application we have is industrial IoT. Industrial IoT in the sense, industries are also making use of Internet of Things. So machines, in early days, machines will be monitored only by human being. Now machines will be monitored by the machines, because we have an IoT which will monitor the machine, and the entire factory can be automated. So there are so many machines which will actually manufacture parts of car parts will be manufactured automatically, and bike parts will be manufactured automatically. So everything is made automated, and maintenance also can be done through IoT. So IoT is playing a vital role in industry also. Which are all the industries which is making use of IoT? The main industries which is making use of IoT is food manufacturing industry, oil and gas industry, construction industry, and electronic industry. So these are all the main industries which is making use of IoTs. See, if you go for industry in 1784, 17th centuries, there was industry 1.0. So 1.0 in the sense, industry which was automated or automatically, what are all the things done is only weaving. So we'll be able to do the weaving automatically. So we can do the weaving in 17th century. That is what the industrial revolution. But industry 2.0, that is 18th century. During 1870, mass production is possible. So they'll be able to assemble the things, and electrical energy was possible during 1870s. That is industry 2.0. But in we had industry 3.2. So during the year 1969, so whenever we came into 19th century, automation started, but not for all the device. We'll be able to automate computer linked devices and some of the electronic devices. So some of the electronic devices and computers can be automated. So that is industry 3.0. So today we are currently we are in the phase of industry 4.0. So in industry 4.0, we are using IoT, Internet of Things, that is connected through the network, and cyber physical systems are there. So everything is made automated. We had so many robots. So we are having firefighting robots, and staircase climbing robots, and drones, which is used in defense. And we have so many robots, robotic arm, so which will pick the device. And we also have color finding robots, which will find the colors. So if you are able to keep a red, blue, black, or different color balls in one basket, if you are asking the robot to pick only red balls, it is able to pick only the red balls. So AI is actually helping IoT in such a way that any decision we wanted to take, so decision making is highly possible, and decision making can be done through IoT. Like human mind, they are able to do everything with the help of IoT. And nowadays, there are so many humanoid robots developed. So everybody might have been heard about Sophia robot. So it is like a human being. Actually, it has got a citizenship in UAE. It is the first robot which has got a citizenship in United Arab Emirates. Actually, that is evolution of IoT. We can say that IoT has evolved in such a way that, like human being, robots has evolved. It is a humanoid robot, and not only Sophia, there are so many robots available now. We have robots to clean a house, and we also have robots to sing song, and for road shows there are so many robots available. So these are all the evolution of IoTs. And in industry level, in mass level, they started producing robots, so which will be helpful to the humankind. And next we have smart city infrastructure. So smart city infrastructure, not only home, not only healthcare, not only agriculture, whatever city currently we are in, the entire city can be transformed as smart city. So how can we transform entire city into smart city? So there are so many things involved. If you take entire city, so you have to manage the traffic, you have to manage street lights, you have to manage the parking system and waste management. So everything can be automated. So that is possible with the IoT. So you can manage the traffic, and you can convert the traffic into smart traffic. So nowadays there are so many research going on. Even now we have driverless vehicle. Now I don't know whether it has occurred in India, but there are vehicles where they are using, in other countries they are using driverless vehicle. Without a driver, they are able to drive the vehicle. You have to just uh, program the device. I think Tesla car can be operated without a driver. So you have to just program the car in such a way that you have to enter the destination and you have to enter the starting place. Automatically it will take you to the destination, it will stop there, and you can get down without a driver. You'll be able to operate the device. So now Tesla car is highly advanced. It has got so many smart applications. And smart traffic management, in the sense whenever there is an ambulance coming, nowadays it's very difficult for an ambulance to travel in a high traffic city like Chennai. So even ambulance is coming, people are not able to give way because it is highly traffic. So if the city is converted into a smart city, if we have smart traffic management, automatically the traffic light will be able to turn on and off when there is an emergency. So the entire traffic system can be automated. Whenever there is an ambulance, automatically the light will be switched to green and it will be turned off. So likewise, everything can be made automated. And smart street lights, we need not go and turn on the lights. See, nowadays human intervention is needed to switch on the light and switch off the light. So street light means particular time we have to go and switch it on, and one person they might have allotted, they have to turn on and they have to turn off. But nowadays we have an automated system. We have to just program the system depending upon the lighting condition. Automatically the street light will be turned on or turned off. If it is very dark, if at a particular circumference, if there is 10 light, all the 10 light will be turned on. If it is somewhat not very dark, if it is some 6 o'clock, not completely dark, some 2 lights will be turned on according to the lighting condition, according to the dim, how dim it is or how light it is. Accordingly the light can be turned on and turned off automatically without the human intervention. Automatically it can be turned on and turned off. Now, even nowadays, this is implemented in some of the malls. I think whenever there are persons entering inside the mall, depending upon the number of persons, the automated system will count the head. According to the head, the number of fans will be turned on and the number of lights will be turned on. So if there is no people in particular area, automatically the lights and fans will be switched off. So likewise, we'll be able to convert a city into a smart city. And we also have smart parking system. See, now highly populated city like Chennai, to find a parking place is very, very difficult. So that also can be made it easy. See, nowadays they are trying to bring an app for parking. See, we are all using Ola app, Uber app, that is for booking a vehicle. But nowadays they are developing a app like for parking. See, wherever there is a parking slot available, even for individual home, if there is a parking slot available, if that person is willing to rent out, and they can rent out, they can enter the parking slot in that app. And if someone wanted to take up that parking slot, they have to go to the app and they have to check in that area. If they want a parking slot, they have to go to the app. They have to check the parking area if that is available, and they'll be checking how much amount they are asking for 1 hour or 2 hour. And after checking the amount, they can avail the parking slot. So this kind of app is also nowadays they are bringing it. Very soon we'll be having app like that, so parking app. So in our area, whichever area we wanted to travel, or we are going inside Chennai, we will be making use of that app, and we'll be able to find out a parking slot, and we can park in that area for 1 hour or 2 hour. So that is what called as smart parking. So next we have waste management system. We also can develop a smart bins. So this is very, very important for a clean area. If we wanted to make our city clean, we have to automate this waste management. We'll be able to develop a smart bins. If we keep a sensor inside the bin, the sensor will check the level of the wastage. So if the actual entire bin is full, the sensor will give a beep sound to the concerned person saying that the bin is full, so that they'll entirely remove the garbage from the bin. They'll make it empty. So once again, they'll be able to use the bin for keeping the garbage. So this is a smart bin. So the entire city can be made into a smart city. The entire city can be automated, so that it be very useful for us to live a very good life, clean life, and also very stress-free life. And we were talking about automated parking system. So this is the diagram showing how to automatically park. Not only to a parking, not only app, for any individual house, we can make it automated. See, whenever I wanted to park my vehicle inside my home, we can make it automated in such a way that the door can be automatically open, and I can park my vehicle inside the door, and the door can be automatically closed. And whenever my vehicle is going in front of my gate, I can make it in such a way that then only the door can be open. Otherwise, I will not allow the door to open. So that can be done through this system, and it has ultrasonic sensor, and it has servo motor. So servo motor will help to open the door and close the door, and ultrasonic sensor will sense the vehicle. It will help to give the information in such a way that whether to open the door or close the door, the Arduino board will process the data. So this is the diagram which is showing automatic parking system, and how the future is connected with your IoT. So there are so many advantages if you come across IoT. Automation is the main thing, and then real-time monitoring. Wherever you are sitting, you'll be able to monitor, and cost saving. So we need not waste our cost. We can reduce labor and increase efficiency, better resource management. So these are all the advantages of IoT. And there are some challenges we are facing: security and privacy. So actually we have to safely handle the data, because since it is IoT, the data need to be transferred to device and to the IoT system. So data handling should be very secure, and device compatibility should be there, and sometimes implementation cost will be high. So in future, actually everything can be made smarter using artificial intelligence, 5G communication, and edge computing. So I think IoT is playing a vital role in each and every moment of our life. Whatever device we are connected with, each and every device can be controlled by IoT, and IoT can make our life very, very easy. I hope this presentation might be useful to you all. Thank you so much. I thank you for the organizers who has given the opportunity to present. Thank you all who has been patiently listening to my lecture. Thank you so much.
Thank you, ma'am. On behalf of Sriram Engineering College, I extend my heartfelt thanks to our esteemed resource person for delivering such an insightful session on IoT application in smart systems. Your expertise and valuable time have significantly enhanced our knowledge. Thank you, ma'am. Now, we would like to open the floor for interaction. If any of the participants or faculty members have questions or clarification regarding today's section, you're welcome to ask them now. If there are no questions, we'll proceed further. Thank you once again, ma'am, for the informative session. Thank you all for active participation and interaction in today's section. Within this, we come to the end of day 4, session 1 of the 6 days online faculty development program on emerging trends in IoT. So, so now the session 2 will be going to start shortly. So feedback form is posted in the WhatsApp group. So kindly complete the feedback form to get your attendance recorded. Thank you once again to our resource person, organizing team, and all the participants for making today's session successful. Have a great evening. Thank you. Start. Start. So good evening to one and all present here. I welcome you all to day 4 of session 2 of the 6 days online faculty development program on emerging trends in IoT, organized by the departments of electrical and electronic engineering, electronics and communication engineering, and mechanical engineering of Sriram Engineering College. And today's topic is IoT in avionics. It's my pleasure to introduce our esteemed resource person, Dr. B.R. Ramesh Babu. Dr. B.R. Ramesh Babu is an esteemed academician and mechanical engineer with over 35 years of distinguished experience in teaching and research. He earned his undergraduate degree in mechanical engineering from Tyagaraja College of Engineering, Madurai, followed by dual master's degree in engineering from Madras University and Birla Institute of Technology and Science, Pilani. His doctoral research completed at Jawaharlal Nehru Technological University, Hyderabad in May 2005. Dr. Ramesh, Dr. B.R. Ramesh Babu has secured significant research funding from prominent agencies such as the Department of Science and Technology, the Ministry of Small Medium Enterprises, and the Tamil Nadu State Council for Science and Technology. His consultancy work spans various industries where he has provided solutions for automation and semi-automation in manufacturing and assembly lines. Under his guidance, 14 PhD scholars have successfully completed their research, earning their degree from their esteemed institution including Anna University Chennai, Jawaharlal Nehru Technology University Anantapur, Jawaharlal Nehru Technological University Kakinada, and Satyabama University. Now, I take this opportunity to welcome our esteemed resource person, Dr. B.R. Ramesh Babu, to take over the session. Sir, we are delighted to have you with us today. I request to kindly commence the session.
Thank you. Thank you for introducing me here, Mr. Parisudharan.
Thank you, sir.
First of all, I like to extend my sincere thanks to the earlier speaker, Dr. G.S. Annie Grace Vimala. She wonderfully given the lecture session on IoT applications in smart systems. And today, my session, I'll share my screen first of all. Is my screen is visible now?
No, sir.
No. Okay. Share screen. Yes. Tap to see. We can. I hope my screen will be visible now.
Yes, sir.
And actually, the many that speakers continuously providing the IoT, IIoT being used in different application. For this faculty development program, the teacher should have some subject clarity so that the deliverables in the classrooms will be sufficiently good enough. We are seeing that the students nowadays coming up with lot of IoT exposures. At the level of school itself, they started working on the microcontrollers and microprocessors. They started integrating lot of projects, and we are seeing they are undergoing the robotics classes and wireless control devices. So all kind of sensors. So temperature, humidity, motion sensors, all the people are using nowadays. But even though when a teacher entering into the class, particularly the teacher who is handling the subject related to the IoT, Internet of Things, they should have some applications. So what the current technology is coming up, rather than we speaking the conventional applications, we have to see what the emerging technologies. So how to be very strong with the emerging technologies and how the global changes are happening. So that and all very important. Today, with some case studies, so how that IoT is being effectively utilized by the aeronautical industry, that I am going to explain it here now. So normally aircraft industry started evolved 120 years back with the invention of the Wright brothers when they made the flying machine, and it was very new, and people admired by seeing the machine with the man flying in the air. Lot of evolutions happened, particularly during the World War One and World War Two. The drastic changes we have observed here. So what happened is the flights with various capabilities, load carrying capabilities, and then huge ranges, all the people have been introduced. And particularly the flight technology which were evolved during the World War being effectively used by us nowadays. And I will go to the presentation IoT in avionics. I'll explain what is the current technology, how it is evolved from the beginning, and what the IoT playing the vital role in the aeronautical industries, and particularly what is avionics that we should understand. The usage of electronics in the aeronautical industry, we used to call it avionics. So I'll go to the next slide. Slide down, page down. Next slide. Yes. I'll go here now. Yeah. Here in this slide, wireless and aviation safety is given. This is the slide what I have taken from the Springer Nature is being displayed here. You see a flight which is flying in the sky. Okay, so what electronics playing the vital role? Many are there nowadays in manufacturing to applications in usage. Many electronic devices it is being incorporated with that one. Some are inbuilt embedded technologies, some are working from the remote places, all making the flight to fly safely and ensures the passenger safety, and so that people can reach their destinations without any struggles. Particularly, aircraft nowadays get connected with the communication satellites. Why to get connected with the communication satellite? And each passage is accurately being controlled with the satellite communications. Similarly, if you see flight controls, many of the flight controls, what nowadays people are doing is it is made automated with the embedded IoT technologies, and even from the far we can able to do the control and air traffic management. So all now normally people used to do from the towers which are situated in the ground support centers, but it can also be made automated nowadays. That particularly the pilots, those who are sitting in the cockpit, without any hindrances, without any difficulties, even the flight is passing through very huge clouds, so they can able to maneuver the aircraft. The word maneuvering means it is the word more related to the aeronautical engineering. So normally we used to say driving. Here we using the word maneuvering. So even the cockpit is totally dark when it is passing through the cloud or in some situations, and the all instruments can able to make the pilot to support and make the flight to fly in the proper direction. So all the navigations and the surveillance can be carried out from the cockpit by the pilots with the instruments over there. So air to ground communications nowadays made very stronger. So at the particular ranges, distance, the communication ground support systems will be provided so that flight can reach the destination without losing its control over the ground. So in not only that, the engine performance is accurately measured. If anything goes wrong, even a small bird hits on the engine, that can be governed by the all the sensor based IoT enabled devices that can monitor and provide the data to the ground support systems. And then black box it carries, it is also totally an electronic system. It can record each and every movement of the flaps, engine, fuel systems, and cockpit conversations. All can be well recorded in the black box. So it is also an electronic device. So aircraft to aircraft communications also required, because so many occasions when they will be going close with one another, so they can able to communicate what distance they have to maintain, where they want to go, what is their destination. So all they can able to do it. Weather monitoring, so that is also very important. Air traffic management, all that they can able to do that one. In addition to that, in-flight communications, so from the cockpit, otherwise from by the crew members, if they want to communicate in the huge aircraft, they require the in-flight communications. So sometimes it may be wired, sometimes it may be wireless may be Wi-Fi connected. And sometimes what happens, nowadays the facilities have been provided in the modern aircrafts to access their internet. So in olden days, we used to say the mobile phones and all the electronic gadgets should be switched off inside the aircraft. Now trend is changing. All they will be holding the separate frequencies that will not interfere with the other communication devices. So like that, new communication systems are coming into existence. Normally, within the aircraft, the electronics controls different control surfaces and engine controls. All they made it electronics. In olden days, what happened when Wright brother invented the aircraft? It was totally mechanical. It is being controlled by the pull and push rods, ropes, gears. All they will be used for leveraging the flaps controls and other devices. Now what happening? And further, the hydraulic and pneumatic control system come into existence, but the control is nowadays taken over by the electrical and controlled by the electronic devices. So what it is now that we can see now, still another 15 to 20 minutes time I have. So within that time limits, what I can able to deliver maximums, that I will deliver. So dear faculty members, those who are attending this FDP, so understand the basics. If it is required, I'll share the PPT also in at the end of the session. So it will be very useful for you people. And here on screen, you can see that aeroplane, which was assembled by the Wright brothers very long back. So this aircraft is a very huge one, only to carry a single person to fly in the air. Okay, so here we are seeing the dual the wings it carries. So it need to run on the runway for long distance to get into the air because of that propulsion system. The engine, the propulsion system was not such a modern one what we are using nowadays. So it has to run for not less than a kilometer on the on the runway to get into the air. So this was the first invention what the Wright brothers have made it, and the people surprisingly looking into the air. The man is made to fly in the air. In such aircrafts, there will be some drawbacks. The fuel efficiency will be very low, and controls, all the flap controls made by mechanical means. So huge efforts, forces to be exerted on the flaps through the mechanical links and wires. So it was very tedious to maneuvering the aircraft. But what happening nowadays? Flight with the biggest sizes flying in the air. But mechanically controlling the devices is impossible nowadays. So because of that, the next stage, that aircraft controls being established with the help of the hydraulic element. Nowadays, that also being you see primary flight control surfaces normally being used in an aircraft is given here. What controls are required? Why to go for IoT? First, we have to understand the various axes. There are three major axes. We used to say in each axis, it carries 2 degrees of freedom. So totally it carries 3 axes, 6 degrees of freedom. With that, so one is the horizontal axis that we used to call it horizontally along the aircraft is called a longitudinal axis, and it is being controlled by the aileron, the wing at the end. Aileron, 2 parts are there. So with that one, we can rotate the vehicle, rotate the aircraft about its axis, longitudinal axis. Rotation is different, and taking a right turn and left turn is different. Okay, it can, this particular longitudinal axis about which we can ensure the rotation of the aircraft with the right side and left side aileron. So normally what people used to do, if we want to control it, both the aileron, one in the up, one in the down direction. If it is right side aileron is lifted up, the left side should be downed so that it can take a rotation about its longitudinal axis. Similarly, if you want to take a right turn, it is different from rotation. Okay, if you want to take a right turn, what we have to do is, for that rudder is there at the end of the tail, vertical, one flap is there, it is called a rudder, which is situated at the end of the tail. So when we will be turning the rudder, either in the right or left, so that the nose means the front tip of the aircraft can take accordingly the directional changes. So if you want to take the flight to the higher altitudes and otherwise lower the altitudes, for that reasons, elevators are provided at the tail. Elevator, both the elevators can be lowered down, otherwise elevated up in order to get the elevation, otherwise lowering the elevation on the air. So how it works? So how it is being controlled? So it is not the aeronautical session, but it is an application we're going to see how the IoT is being used in the aeronautical field. It's called avionics we're going to see. So first we should understand the fundamentals. That's why I have shown this diagram. The next one, the clear picture, a very clear picture. So what is flap, what is spoiler, what is ailerons, rudder, elevator, all have been given here. So all it's a sophisticated one, And here, now, as I explained little earlier, both the wings carries the aileron at the extreme ends. So aileron helping the aircraft to rotate about its longitudinal axis. Similarly, rudder helps to take the right turn or left turn. Elevators help that aircraft to go up and down. So these are all the things indicated in a right yes way here. And multiple engines, sometimes single engine, two engine, four engines, all different types of jet engines, jet ram engines. So like that, various engines it carries. That is away from our subject. We can go to the next. So doing those controls, flap controls, okay. So vehicle can be that aircraft can be made to roll. Otherwise, it can be elevated up, elevated. The elevation can be lowered. All we can able to do it. I hope in the lower diagram there will be a circle. The circle in the first part you can see that one in the circle, the horizontal elevator is shown as a line over here. The line is lowered. When this line is lowered, what happens, this air which is striking this elevator, it will be pushed down. Because of that that elevator is taking a upward motion. The center of gravity point is at the center. About the center of gravity, the tail is when it is lifted up. The nose is get dipped, so that the flight starts traveling down towards the earth. Similarly, the next diagram you can see that up elevator or nose up is how it is. Nose up is happening. The elevator is made up. So by the time the upper side air which is striking the elevator is pushing the tail down. When tail is pushed down about the CG point, the nose is lifted up. So this is the fundamental we should know. So with that, actuators, what actuators it carries, what kind of sensors it carries, that are all we can see now. So this is the diagram which indicates harnessing IoT in aviations. So some benefits, top benefits, what it get. So IoT is required. Nowadays it is unavoidable. So in a flight controls, all the accurate flight controls manually performing is impossible. So a lot of manual errors are prone to occur. Whenever the manual errors are happening there, and the losses will be very huge. Recently also we are seeing in getting the news through the news channels that flight accidents, all sometimes it may be manual, sometimes the instrument embedded systems, when it is not work properly, when it is failed to give the communication properly to the pilot, otherwise to the ground support engineers. So those times also the problems may happen. I'll start. What are all the things to be made there? So first I'll start with this place. Environmental monitoring is very, very important. Environmental monitoring. Why environmental monitoring? What is environmental monitoring? So how humid is that surroundings? How dense cloud is present there? What is the velocity of wind passing through? So like there's so many things influences the flight of that flying machine. So what happens? Environment must be properly monitored. When it is a very rough in weather, otherwise very huge air is passing through, and sometimes where the cloud totally get accumulated on the ground. So landing and takeoff also becomes sometimes very tedious for the pilots. In such cases, instrumental landing, instrumental takeoff, all being used. But even though nowadays, still the people, the avionics people, looking for the more intelligent support from the engineers of you people. So faculty members, you should understand environmental monitoring and then providing the support all with you only. We have to mold the students towards environmental monitoring and control systems awareness providing, so that flight can be made to fly without any difficulties from takeoff to landing. It will go well. And predictive maintenance. So some maintenances we can able to predict in advance. So that kind of maintenance is required that can be carried out with the IoTs. So certain things, some noise, because that engine which is running over there is not 1000 rpm or 10,000 rpm, it is in lakhs. So in a turbo engines, the engines that blades very closely placed. Stators and rotors are very closely placed, so that all streamlined flow should be proper enough. In such engines, a small bird hit also lead to the major failures. So we have to see that what changes in the vibration. For that, some sensors are required, needed. The kind of sensor we use for predicting the changes in vibrations all is called vibrometers are there, some other sensors are there. So with that one, so what is the vibration levels, all we have to monitor, and we have to see that whether the engines are working properly, air pressure inside the system properly being maintained, even when it is passing through the higher altitudes, that cabin pressure should be well maintained. For that also, various type of sensor we are using. Temperature sensors are there, humidity sensors are there. If the flight is carrying only the machineries means machines, otherwise the letters or some papers means no need to be worried. Temperature we no need to bother. Humidity we no need to bother. Oxygen level present in the air we no need to bother. But when a human being is flying in the flight, so all these criteria should be well monitored. So temperature is very sensitive. Humidity is very important. Air should not be stagnant. Air velocity is very important. So above all, oxygen level is very important. Altogether, we used to call it air conditioning and cabin pressurization. So like that, so many things are there. So operational efficiency, cost reduction, enhanced safety, all these things are possible when we go for IoT inside that aircraft. Okay, I'll go to the next slide. So here I have given the conventional sensors normally being used by the electronics engineers nowadays. So these are all the things. I'll read one or two here. The thermistors. What the thermal sensors and thermistors having some differences. Some thermal sensors can measure what is the temperature over there. Okay, thermometers it is called. It is a thermistor means when temperature exceeds the limit, when crossing the limits, it can do the switching on and off operations. It's called thermistor. IR sensors, infrared sensors. It is for the distance measurements where we can use it. So there is some types are there. Transmissive type, reflective type, all are there. Ultrasonic sensors. So all see some sensors are wired, some are wireless sensors. So gyroscope sensor is a very, very important in the flight control. So what is the flight position in the air? It's very important. And sometimes it is taking a rotation in right direction, rotation in the left direction, all gives the discomfort for the passengers inside the aircraft. So gyroscopic sensors are very important. So on the cockpit screen, what is that gyroscopic position of that aircraft should be well displayed so that corrective action can be taken by the pilots. So if it is leaning down in the right or left, so it can be corrected. Nowadays, it is also being taken over by the IoT. So all the embedded technologies, it measures what the angle it is deviating, all it can be measured and it can be rectified over there. Accelerometer. So vibrometer, I mispronounced a little earlier. It is actually an accelerometer. Accelerometer is not meant for measuring the velocity or speed. Its accelerometer is used for measuring the vibration over there. And rain sensors. So like that rain sensor is very important. What is that water falling over there? Sometimes it become dry. So why it is very dry, what situation it will be very dry, in the flaps, sometimes accumulation of ice, and when it is passing through the humid environment, the water content started deposits on the flaps. What happens in emergency if you want to do the control after a long flight for a few hours, you cannot able to do it, you cannot able to do the flap controls, okay, because the ice which is get frozen on the flaps gives lot of troubles. So these are the different common sensors. Some are how it can be used in the aircraft industries. All you people, if you understand well, when you'll be delivering the subjects in the classroom, you can able to do it in a better way. Now time is nearing 7:30, but even though a lot of PPTs I have to display here, and here primary flight control surfaces and being controlled by different transducers. You know the difference between sensors and the transducers. So the transducers actuating the flaps and other, even the landing gears and some fuel controls, all being controlled by the various transducers over there. So some of the transducers I have mentioned here. So many are hydraulics, because sometimes nowadays servo motors are taking the prominent position in aircraft industries because of compact, lesser in weight, and more accurate. So olden days, we doesn't have compact servo motors, even DC servo motors, AC servo motors. The olden days, what happened, so lack of electric drive systems and solenoids, we people using the hydraulic and pneumatic control systems. They are heavier. Nowadays also, even the landing gear, some flap controls, when the flight is being landed on the ground, so braking can be applied with the flaps only. It is turned down. So for that reasons, conventional electronic devices and electrical devices, in many cases, people not believe. But slowly, the changes are coming up because of the compact devices capable of providing heavy torques and doing the controls more effectively. I'll go to the next slide. Fly-by-wire control loops. What is fly-by? See, I mentioned different sensors, different actuators are being used in an aircraft, but the how to communicate to the particular sensor, get the communication from the sensor, how to provide the communication to the actuators, all in different mode we can able to do it. One is through the wired control, another one is the wireless control, okay. But people not believe nowadays, still the technology is coming up. In most of the flights, people believe only on the wired control loops, wired control devices. So why means nowadays also, when flight is about to take off, about to get landed, the announcement is being made, please switch off your electronic gadgets. Means that interference also lead to misguiding the aircraft sometimes. So people believe the wired control loops, which will not take much more interference from the any electronic gadgets, and also outside the aircraft also, sometimes some people can try to take over the control of the aircraft. So in order to avoid such a problems, the wired control loops are being mainly used. So pilot inputs through the joystick, they will be doing. Flight control computers are there inside. Flight control computers are there inside. It is controlled by the pilot inputs through the joysticks, and then actuators which are controlling all the flaps and landing gears and everything over there. Whatever the things to be controlled, all can be controlled by the various type of electrical and electronics actuators. And aircraft responses can be monitored by the control that through with the control surfaces being monitored, and feedback sensors are there. So what the signal we provided, for that the response is proper or not, and any what corrective action it should take, it all it can able to do it. And feedback sensors finally it go to the pilot input. And then this is one part. Now still lot of things that IoT is doing, autopilots. If I want to, if the flight has to reach uh, reach Chennai to we have far distance. Yeah, direct flight to Singapore. Otherwise, still farther. Etihad's flight going to some Middle East. Otherwise, British Airways want to have a continuous flight up to the London. In such cases, autopilot is being nowadays used for that one. What the work the pilot has to do is, before it take off from the ground, the destination, and then that necessary data to be fed to that one. It is given here. Before takeoff, the pilot will enter the route into the computer, so which given in the beginning and end of the trip, and how to fly there. So all should be well given. So that once the data is provided, that work of the pilot and co-pilot become very simpler in the aircraft. See that now big aircraft being manufactured with various industries. The industry people are saying efficiency increases nowadays 30% because of the implemented that IoT being implemented in the aircraft. So the IoT, the controls being made within that aircraft through the wire, and from the ground it is wireless, and through the satellite it is get connected, so that the directions are well monitored, where it should fly, where it should not fly, all can be predicted, and alterations can be made. So lot of advantages, safety and fuel efficiency, all it is happening in the flight. Some of the features what it carries inside the aircraft: electronic flight bags, so in-flight payments, so many things are there. So electronic flight bags are there, so it protect the people in some situation. In-flight payments, so inside the flight itself, if they want to buy it, they can able to make the payment through digitalized IoT enabled digitalized mode. Predictive maintenance they can able to do with this IoT. So like that, so many works that being simplified nowadays with the IoT. Driving change through innovations, that are everything I explained. So in the aircraft industries, that passengers having the comfort, so from the state of booking the air ticket, and then before they getting into the aircraft, they can able to confirm the ticket, and all they can able to do with the computers, all for that big datas or cloud datas all available, so that they can able to do they themselves. No need to go to the airport, particular lounge, otherwise particular counter, all can be minimized nowadays. And see that it is a old aircraft where that both the pilot and co-pilot, both of them, the he and she, sitting in that aircraft, and the altimeter, and all the control units, and fuel meters, and speedometers, that velocity at which it is going on, and the direction monitoring systems, and fuel level indicators, all will be given in the cockpit dashboards. So in old aircraft, what it is shown here, it indicates all will be analog. Nowadays also in digital world also, in IoT technology is being incorporated for the pilot convenience. It can be made rather than digital. It can be made more analogous nowadays. So very closely the pilot cabin has been shown here, and so all made the passengers flights and goods flight to fly safely on the sky. And with these few slides, I'm closing my session, and if any questions are there from your end, you can raise it now. Dr. S. Ramesh.
No question, sir. Thank you, sir. Thank you for your informative session, sir.
Yes,
Thank you.
thanks a lot, Ramesh, sir.
Thank you. Thank you.
Very happy. Okay, with this one, I wind up here now. Okay, thanks for being here with me. And I hope this session will be very useful. And if you require any slides to be shared with you, I can do it.
Thank you, sir.
Thank you.
On behalf of Sriram Engineering College, I would like to convey my sincere appreciation to our esteemed resource person for presenting such an informative session on IoT in avionics. Your valuable insight and time has greatly contributed to enhancing our understanding. Thank you, sir.
Thanks a lot.
With this, we come to the end of day 4, session 2 of 6 days online faculty development program on emerging trends in IoT. We look forward to your enthusiasm participation in tomorrow's session. So the feedback form has already shared in the WhatsApp group. So kindly make sure your attendance is recorded. So once again, I thank our resource person, the organizing team, and all the participants for making today's session a success. Have a pleasant evening. Thank you.
वहाँ सूरज बाजार बगड़े भी वहाँ बदले वहाँ आगे पे राउंड देगा